are going to look at lengths of segments in circles. So we have 3 theorems. For the first one, the first one says, in a circle, when we have 2 chords that intersect, the product of the segments of one chord equals the product of the segments of the other. So when those 2 segments or chords intersect each other, they're broken into 4 pieces. So I'll label those pieces A, B, C, and D. And this theorem says the product of the pieces of one of them will equal the product of the pieces of the other one. What does product mean? Multiplication.
Does it matter which letters you use for?
It doesn't matter where those letters go. But we want to multiply the 2 pieces of one chord and set that equal to multiplying the 2 pieces of the other chord. Okay. No, the 2 chords are not necessarily equal to each other. The sums of them are not equal, but the products are. Good question, because that's actually the most common mistake that students make with these, is doing a subtraction to get a missing piece instead of doing products. The second theorem says when 2 secants are drawn, so secants are like chords that just keep on going. It says the product of one secant segment and its external segment. So what that means is when we have a secant, we're going to consider the whole length and the outside part. Not the inside by itself, but the whole thing and the outside. And then likewise for the other one, the whole thing and the outside. And since it's still a product, that formula would still be the same when we label it this way. That A is the whole length, B is the outside, C is the whole length, and D is the outside. So when they intersect inside, our first theorem said we'll look at just all the broken pieces and multiply those. But if the intersection happens outside, we want to take the full length of the secant times just the outside portion. So we do not deal with the inside by itself in a secant. And the final theorem says when we have a secant, like in the last one, and a tangent, the secant will do the same way, so whole thing times outside. But a tangent only has one piece. It just has that one chunk from its point of tangency to the intersection. And since all of these theorems are talking about multiplying, since we have nothing else to multiply it by, it says multiply it by itself. It says it's equal to the square of the tangent section. And squaring is just multiplying by itself. So for the secant, we'll do the same thing, whole thing times outside. But when we have a tangent, since it just has one piece, we multiply it by itself, or square it. So chords, if the intersection happens inside with chords, multiply the broken pieces. If the intersection happens outside with secants, whole thing times outside. And then if there's just one piece because it's a tangent, we multiply it by itself, or square it. So let's look at some examples of these. For the first one, upper left, what equation would I set up to solve this? The first theorem, so what would that equation look like?
X times B equals 6 times 4.
Multiply the broken pieces of one of them equals multiply the broken pieces of the other one. So 3 times x equals 6 times 4.
Maybe we just leave it like that.
Well, we want to solve for the x. So 6 times 4 is 24, and divide that by 3 gives us 8. Okay. So we already mentioned this once, but I'm going to tell you the most common mistake that students make is saying, well, the one chord has a length of 10, so the other one must have a length of 10 as well, and saying that x is 7. That is not true. Some chords in a circle are very short if they're close to the edge, as opposed to the diameter is going to be the biggest chord in the circle. So all of the chords are not the same length. So we cannot do it by subtraction, but our theorem told us we can do it by multiplication and division. So multiply the broken pieces of one should equal multiplying the broken pieces of the other. Top middle, we've got secants. What would I set up for the upper secant? What's our rule for a secant? 8 times x. Whole thing times outside piece. So when it's a secant and it goes beyond the circle, we do the whole thing times the outside piece. So 8 times x. And then what about for the lower one? 12 times 4. 12 times 4 is 48. So x is equal to 6. For the third one on the top, what would I set up for the upper secant? Our rule is what for a secant? The whole thing. So how do I do whole thing on that top part since I know the two pieces? 6 plus x. Whole thing times outside, which is 6. Okay? So for a secant, you need to do the whole thing. So if you know the two pieces, you have to add them up to get the whole thing times the outside. On the bottom, what would the whole thing be? 5 plus 7, which is 12. And then times 5. Okay? So when you know the pieces of a secant, you have to do the whole thing. So you have to add up those pieces times just the outside portion. What would I do next to solve this? Distribute. So 36 plus 6x equals 60 is 12 times 5. Then what? Subtract 36. That gives 24. So x is equal to 4. Okay. For a secant, whole thing times outside. So first one on the bottom, we have a secant. What would the rule for that secant be? Nine times x. Whole thing times outside for the secant. Then we also have a tangent. What's our rule for the tangent? Square it. There's nothing else to multiply it by, so we'll just multiply it by itself. So 6 squared. What is 6 squared? 36. So x is 4. And for this final one, what would we do for the secant?
6 plus 2
times 6. 2.
And then for the tangent, x squared. So for the secant, whole thing, and since we know the two parts, we have to add them to get the whole thing, times the outside piece. And then for a tangent, there's nothing else to multiply it by, so we multiply it by itself. X times x is x squared. So that gives us 8 times 2, which is 16. So x would be equal to 4. Questions?
I have a random question. Is it okay to get decimals in these?
It is okay to get decimals, but if the decimal is messy, I want your answer as a fraction instead. So if it's like 0.5, that's fine, but if it's messy and you would need to round it off, you should use a fraction instead.
So
So homework is from 9.7.